What's up, yo? Totally not at the mall right now. Totally, at my house in a professional setting to record this video. But we're gonna talk about some calculus and some Pokemon Go. So here we go. So the reason I'm here is to show you that location matters in Pokemon Go. As you can see right now, I'm at a Pokestop. So that means there'll be more Pokemon around. The thicker the location and the more Pokestops you're around or gyms you're around, the better the Pokemon will be. It also depends on the type of Pokemon. Today it's not a very good example, as you can see. They're all the same Pokemon because it's May Community Day, so they highlight one Pokemon. But as you can see, in a popular location like the mall, there is a lot of Pokemon. While in some other clips you may see, there may be very little Pokemon if it's by a house, neighborhood, where there's not a lot of people playing, and that there's not a lot of Pokestops or Pokegyms. One thing I don't know that I want to find out is, does the time that you are playing have anything to do with how many Pokemon appear? As well as, does the distance you travel have any effect on that as well, or the combat power of the Pokemon you find, or the strength of the Pokemon that you find? The escalator's out. I just had to walk down. So my goal is to use calculus to find the optimal time to play Pokemon Go, as well as what distance you should travel in order to get the best Pokemon for the least amount of effort used. Because why would you do more effort? That's dumb. Now I'd love to go through all the calculus at the fashion mall, but I'm gonna be late for start work, so we gotta go. I'll do that later.
I turned the nightclub bad at the basement. I turned the plane around your ass.
So to track this data that I wanted to take, I tracked multiple things. I tracked the amount of Pokemon I caught, what time I was catching them, what the date was, how much distance I traveled and location, as well as the total CP of all the Pokemon, which is their combat power. And by the way, I'm not driving right now. That's a green screen. So as you can see in the data in this column, we took the average of all of the CP caught by the Pokemon, so we can see the average CP of the Pokemon we caught in that time frame. So now we're gonna use calculus to find out the average amount of CP in the amount of time that we spent playing the game. I just did 30 minutes of work and then realized I was just doing algebra, not calculus. So yeah, that's a lot of fun. Apparently, you have the best chance of playing Pokemon Go at 4 minutes time length, but yeah, on to the next thing. I'll be using the unit of derivatives for the first problem. The first variable, x, equals the amount of Pokemon caught. Omega equals distance traveled, and NL equals the average CP of Pokemon. And the first graph, you can see NL on the y-axis and Omega on the x-axis, or the distance traveled. The equation of the trend line of this graph is 443 plus 205 Omega minus 143 Omega squared. Next graph, we see the amount of Pokemon caught on the y-axis and Omega, or the distance traveled, on the x-axis. Gives us 6.12 minus 26.4 Omega plus 45.6 Omega squared. If we take the derivative of this equation, we get d and L over d omega, which equals 205 minus 286 omega. If we set this equal to 0, we can find the critical point, or the absolute max. And this occurs at omega equals 205 over 286 kilometers. At this point, the average CP will be the highest for the distance traveled. Additionally, we can take the derivative of the second equation, which we get dx over d omega equals negative 26.4 plus 91.2 omega. If we set that equal to 0, we also get the critical point for that, which will give us absolute min for the amount of Pokemon caught, which equals omega equals 0.289 kilometers. So at this point, we know that we should stop playing Pokemon if we're going for amount of Pokemon caught and wait for the service to reset in 15 minutes.
You know how there's like different type of learners, like kinesthetic, like visual and audio? I wonder if you get that from like how you were raised as a child, like how younger siblings with older siblings that can already walk learn to walk at an earlier age because they watch their siblings walk. I wonder if that turns them into like visual learners, sort of, like how else does that work? What about like dogs? Is there a different type of learning for dogs? Right? Some dogs teach them to sit, you gotta like push their butt down. But for other dogs, you just tell them to sit and they sit. Well, I guess not. Who knows? You may see a little sign pop up right now on the gameplay that says you are going too fast, right, passenger. And just so you all know, I am a passenger. I'm not driving the car. My friend Ellen is actually driving the car. And we're going to the hospital or something. I don't really know.
For this problem, I'll be using intervals. The first variable t equals the time of day in hours, and x equals the amount of Pokemon caught. Points I plot for the y-coordinate is the average value of x for each session played. And for the x-coordinate, I took the middle of the time I was currently playing, so the start time plus the end time divided by 2. If you look at the graph, you can see it's a 24-hour clock of the time played, and it gives us the equation x average of t equals 0.239 minus 0.157 t plus 0.0354 t squared minus 1.23 times 10 to the negative 3 times t cubed. If we take the integral from time 0 to time 24 of x average of t dt, we'll get the value of 21.622. This is the average amount of Pokemon I would catch in a 24-hour period of playing, with the average amount of Pokemon I catch each hour through the data I've collected. Wow, that was so crazy. We used calculus with Pokemon Go.
Whoa.